Thanks for stopping by at the eCave. In this episode, I'm looking to restore my old IBM 5150 PC, plus the 5151 green screen monitor that came with it originally. This PC was actually made here in Australia, so I'll tell you a bit about that before we start disassembling it. If you're interested in that, please join me in the eCave. Well, great. Thanks for staying. As I mentioned, this 5150 IBM PC was manufactured here in Australia in a factory which is located, or was located, in the city of Wangaratta in the state of Victoria. Interestingly, this factory actually began back in the 1970s or 1976. And they were producing IBM Selectric typewriters at the time. They decided to modernize and phase that out in April 1984 after having assembled over 100,000 Selectric typewriters, and converted the factory to begin manufacturing, or more appropriately, assembling IBM PCs. The Wangaratta factory was the third factory in the world to begin churning out IBM PCs to try to meet the demand. The first one was in Armonk in New York in the US. The second one was Greenock in Scotland, and Wangaratta was the third one. They actually assembled or produced IBM PCs, XTs, 80s, and even PS2 machines, and some of the RISC 6000 series in Wangaratta. But in the early days of producing or assembling IBM PCs, IBM here in Australia had high hopes of sourcing local manufacturers to produce parts for the IBM PC. So they were hoping to get up to 25% of the content made here in Australia, with the rest of it imported, and then the IBM PCs assembled in Wangaratta. Sadly, that didn't pan out because the IBM Australian manufacturing at the time wasn't up to it. When this PC finally came out of the factory, it had one item which was Australian made. Yes, it was the power cord. Nothing else. Everything else had to be imported. Now, this factory actually operated until 1998 and was sold to another company called Bluecom. But shortly after, that company went broke. And a few years later, it was acquired by a US company called Selectron. They rationalized and simply closed down the Wangaratta factory in 2000s. Thus ended IBM's manufacturing in Australia of computers. Now, let's look at the PC in more detail, and then I'll take it apart. And of course, I'll have to take everything out of it. We have to look at the power supply to see if it has any of the bad capacitors, the reefer ones. And of course, the motherboard needs to be looked at in relation to shorted capacitors, which are the two most common problems with the IBM PC, apart from any memory problems. So hopefully this episode won't turn into a part 2 or a part 3, but we'll find out. So first, let's look at the machine in more detail, and then I'll take it apart and we'll start looking at the power supply first. We can test it on the bench, and then we'll test the motherboard on the bench, and then I've got to do a fair bit of cleanup because the machine doesn't look like it's very pristine. But we'll see how that pans out as well. So here's the machine. You can see that I've got the original keyboard, the system unit and the monitor. They sort of look okay, but when you look at the machine here on the side, and you'll see it a bit better when I take off the monitor, the system unit isn't very good. And here at the back, yeah, the usual outputs. That looks like an MDA card and a floppy disk card. Now I'll take the monitor off and we'll look better on the outside of the system unit. Well, here's the outside. It looks pretty dirty, so I don't know how well that will come up. The other side isn't too bad, but similar to the top. The monitor is unbroken, unusually, so you can see the tabs for the screws to take the cover off are pretty yellow. Ignore the blue label. These are just numbers I keep in an Excel spreadsheet so I can catalog all the systems I have. Like this one's 1110. So I've written down all the serials and things like that. Now, as you can see, this machine has 2 floppy drives, and there's nothing left to do but slice it open. For that, we have the good old screwdrivers, original from IBM. So let's get started. First thing we have to do is, of course, open up the back and take the screws. Well, this one, let me see. It comes out by itself. Interesting. There's another one here. And I can see the other screws are not there. But you can see here, manufactured by IBM Australia Limited, Wangaratta. So cool. So let's slide the cover off. Put that away. And here we see it. There's the 2 floppies, the power supply, and that looks like the floppy controller card, which we'll of course have to take away. I'll put that aside. And here's an MDA graphics card. The original, I guess. No, it's not the original. It's missing the pin header. It's a later version. So I'll put that aside and let's take it apart. Now I'll put a chassis aside, and here you see all the bits. This is what the IBM PC consists of. Essentially, it's the motherboard, 1 or 2 floppies, depending on your configuration, the MDA adapter to drive the green screen monitor, and the floppy controller. Nothing much to it. And then of course on the back of the motherboard you had the keyboard and the cassette interface. That's what you would get in the early days. But let me look at when this was manufactured. See some date codes. Yeah, 8405. So this is probably made 1984, late 1984. And the BIOS, what version of BIOS does it have? That would be U33, this one here. Bit hard to see this due to, there it is. 1501476. That's the 3rd revision of the BIOS. There you have it. The first thing, of course, is take the power supply apart and find out whether it has reefer capacitors and replace them, and then bench test it to make sure it's producing the right voltages. Let's do that. Okay, here we have the power supply on the bench. So it's time to take it apart. The fan is, of course, in the lid, so we have to take the fan out. But let's see. Oh, look at that. Let me get the fan out here. Put that away. Couple of lovely reefers in there. Wow. I hope you see them. There's one, and there's the other one. Yep, they've got to go. We don't want them to blow up. So I'll take the board out and replace the reefers and clean this up a bit. It looks fairly dusty. Well, I'm back. I've cleaned the chassis itself. I've also cleaned the PCB, which looks a lot nicer now. I can't notice anything untoward on the PCB. I've replaced the 2 reefer caps with more modern caps, and where did I put them? You can see the cracks where the smoke will escape, at least on this one. This one has fewer cracks, but this one is definitely potential for blowing up and creating smoke. So throw them away. I've also set up here to test the fan. So let me see if you can see that. Give it 12 volts and it sounds like music. It says DC 12 volt, 0.12 amps, but it's only drawing about 70 milliamps, so looks like this fan is good. Now I'll assemble this and then we'll test the power supply and see if it outputs the right voltages. Now we are ready with 2 drives and we'll see what happens. Hopefully nothing terrible, but here goes. And it comes on. So the next thing we've got to do is measure the voltages. Let me get a voltmeter and get that set up so we can all see what the voltages are on the power connectors. All right, here we are, ready with the voltmeter. I'll just ignore the hard drive. I know it's faulty, so that's why I'm using it. So we have negative here, and we should have plus 5 volts here. These are the motherboard connectors, plus 5 volts here. Another plus 5 volts. And the third one is minus 5. Minus 499. Pretty good. Next connector, motherboard connector, should have 2 grounds, minus 12, which is minus 11.6, plus 12, and pin 1 is power good, which is 5.27, so looking good. And the, let's see, oh, we'll have to disconnect this one and check this one with 2 grounds in the middle, plus 5 volt, which is 5.3, and plus 12 volt, 12.48. I think this power supply is working, so all good. Next, the motherboard, checking for shorts. While I was working on the power supply and checking the voltage output, I had a page from the IBM Technical Reference Manual giving me the pinout. So that's where that comes from. When it comes to checking the motherboard, there's another useful manual called the Hardware Maintenance Service Manual. It has something called MAPS, which is a short for Maintenance Analysis Procedures. In the early days of computers, they created all these flow charts to diagnose computers. That's before they began using software and automate the process and get rid of all the engineers. But anyway, the maps give you a flow chart. You go through each step and answer it yes or no, and then the map directs you in a different flow. Now, one of the procedures looks at the power supply and ends up measuring the resistance to ground from the power supply whilst disconnected from the power supply itself, so without power. Now I pulled that page out of the hardware maintenance manual, as you can see here. It's not complicated. It starts from pin 1 to pin 12, and it tells you here what kind of resistance at minimum you should see. So basically it's checking for shorts. So if you don't see these resistance values or higher, then something's wrong. Now the first pins to check is to put the common lead, which is the negative, on pin 5. 1, 2, 3, 4, 5. And the ohm lead on pin 3. Pin 3. And as you can see, there's nothing. If I put them together, you get the short, but pin 3, nothing. That's good, no short. Then the common lead on pin 6, which is the next one, and the ohm lead on pin 4. 1, 2, 3, 4. Yep, once again, nothing, which is good. The next one is the common lead on pin 7, and the ohm lead on pin 9. So 8, 9 would be this one here. And once again, nothing. If I short them together, yep. But on pin 8, nothing. And then the common lead on pin 8 for the remainder, and we check 10, 11 and 12. You should have at least 0.8 ohms. So we have 10, 116.1, 11, same value, and 12, same value. So this procedure tells you that there's no short on the motherboard. Now, is that guaranteed? Of course not. As soon as you apply power to the motherboard, one of these caps could blow and short and you get loss of smoke. But that's the next thing we'll try. We'll just try it here on the bench and see if that happens. Well, it's all set up. The power supply hooked up to the motherboard, and nothing left to do but to power it on. Let's see what happens. Oh, did you see that? The power supply shut down. That does not bode well. Looks like there's a short, or a short has developed. So what to do? Well, let's try it again. Yep. Well, maybe it was a bit of a fluke. I've got the speaker hooked in. So if the board works, we should hear some beeps. So let's try that. Oh, 1 long and 2 short. That sounds pretty good to me. It's like music. It simply means it's past its post routines and was checking for a graphics adapter. That is excellent. We can now take it over to the other table, give it the graphics adapter, hook it up to the monitor, and see if something comes on it. Well, I'm back at the test bench where I'm going to power on the motherboard. As you can see, I put in the MDA graphics adapter, and let's hook it up. Now, I've got a GoPro camera pointed at the screen if something happens to the screen, so we can all see that. I also plugged in the keyboard, so there's nothing left but to power this on and see what happens. The monitor, of course, is plugged into the power supply at the back via a female connector. So it should receive power as soon as I power on the power supply. So let's try that. all the switches. Oh, sorry, oh, the monitor works, but we're getting parity check 1. Well, of course it had to be a memory error. So I'll leave that to the next episode. We'll finish here, but I'll be chasing this parity memory error in the next video. This has become too long, so I'll leave you now. Hopefully I'll get the next video out quickly as well. Until then, thanks for stepping inside my eCave.